Okay, we will get started in just a moment. I am going to start sharing my screen. Okay, so we'll go ahead and get started right here. Okay, so welcome to the information session, everyone. My name is Raja Iqbal. I am the Chief Data Scientist and a lead instructor at Data Science Dojo. I'm going to go through this boot camp, and this boot camp, we have been doing it for quite some time. We have I don't know if I have the exact number, but the number of graduates from this bootcamp in both the public setting and enterprise setting, it goes somewhere over 6,000-ish, right? So, and I'm talking about in person and the virtual settings. So we have been around for quite some time, one of the oldest and most respected players in the data science bootcamp space. Many people who are in leadership roles at big companies, big analytics and data science and otherwise companies, they have actually graduated from our bootcamp. And we'll be sharing the links and you can go and verify, who those people are. And maybe you're connected to some of them. In all, we are probably crossing now 11,000 people who have gone through our training programs. And I'm talking about the 11,000 people that we have trained. It is either in an in-person setting or in a virtual setting where the training is still live, but they went through our training programs and the online footprint, online videos and trainings and free tutorials. We don't really have track of that because we are one of the biggest communities in that space as well. Okay, so I'm one of the lead instructors. I started my career at Microsoft Bing, and started at Microsoft when machine learning was not mainstream. Started at Bing, worked there for a few years in online ads, experimentation, fraud detection, relevance of ads, and so on. And then eventually went ahead and founded Data Science Dojo. And this is our footprint, close to 10 years now. 3,000 plus companies globally. Any company that matters on the planet, someone from that company has attended our training. Probably every country on the planet has been represented in our trainings. And once again, it is in-person trainings or virtual trainings. I'm not talking about, an online, massively online open courses platform. So how does the bootcamp work? What we have done is, it's a 40-hour, 5-day bootcamp, and all you need to do is just bring your laptop and everything else. Any coding sandboxes, any subscription, anything else, you just bring it in, and then we enable you and empower you, right? So, I will go over the curriculum and also answer any questions about the curriculum. I will spend more time on the curriculum than giving you details otherwise, because curriculum is the most important thing. What is the class format? The class format looks like this. So it is an in-person training that the next one that is happening, it's happening in Seattle. It is an in-person training, but also there are people who would be attending virtually. They will be attending remotely. So it's some people are in person, some people are attending remotely from the comfort of their home, for their homes. And then for various reasons, because of scheduling conflict, maybe because of budget, people cannot travel. So we have, if you notice this small device here, right? So basically, this is a 360-degree, conferencing equipment that actually makes sure that the people online, they can interact with people in person. So we try to mimic that in-person experience as much as possible for people who are attending remotely. And so far, we have had great feedback. So what do we cover in this bootcamp? Let me just dive right in. The curriculum actually includes more than just technology. Data science is far more than just knowing some Python libraries or some techniques, some building some models, and so on. We take pride in the fact that everyone who teaches at this bootcamp, they are practitioners. I still actually deliver things on the services side and the product side. We have a lot going on besides the training aspect of it. So you will hear from people who are actually building things. So you will hear about the business aspects. You will talk. We will also talk about the communication aspect, the business aspect, the project management and product management type angle to it, expectation setting angle to it. So it's a combination. It's a fairly intense bootcamp when it comes to technically. It's a very fairly technical and intense bootcamp. But at the same time, it is um, it is not only about technology, right? So so we'll talk about the theory, we'll talk about the programming and the practice side of it, we'll talk about the business aspect of it, and really everything all the skills that a data scientist should have. I will go on to actually show you the curriculum here. Let me go here. So even before you come in, one of the questions that we get is, I do not have any background in data science. I don't know any machine learning. For that matter, sometimes people ask, I'm not a programmer by training. So if you're not a programmer by training, or if you have not done any machine learning, you don't have a strong math background, can you do it? Yes. So before you come in for the training, we'll give you some prep material where you will go through some tutorials in very basics and fundamentals of fundamental ideas and concepts that will come in handy when you come in during the bootcamp. We'll also have you go through. Excuse me. We'll also have you go through some Python tutorials, enough for you to actually hit the ground running when you come to the in-person bootcamp. Um, when you come in during the in-person bootcamp, it is going to be a combination of lectures and practice. So we will be delivering, live lectures, of course, and then we deliver the lectures, and the length of lectures varies based on what topic it is. For some topics, it's more theory and less application and less practice, and then in some cases it is the other way around. Depends upon the topics. So the content is, think of this as about 16 to 20 modules. Uh, we start with a strong emphasis on the data fundamentals. We do not even go to machine learning. We do not even talk about machine learning until we have what figured out the data aspect of data science, right? So we emphasize a lot on the how do you actually collect data? How do you ensure the quality of data? What could go wrong if the quality of data is not there? We talk about this strong emphasis on the quantity, quality, variety of data. We talk about hypothesizing, right? So I have some data. How do I hypothesize? What other data should I be getting? And how do you identify any problems by looking at your data and looking at your visualization? So in many cases, let me actually show you one of the exercises. So we'll talk about all of that. But when we have discussed the theory part of it, after that, we will go through these Jupyter notebooks, and all of you will get your own dedicated storage and compute for in our notebook environment. We have hundreds of code samples. We do some in class and leave others to you for practice. And the reason we do it this way is that in many cases, we end up in the past having gone through like 5 or 6 thousand people that we have trained. We have found out that it is setting up the environment, your Python virtual environment, dependencies on Mac or Windows. It can sometimes be actually time consuming. It eats away time from our actual discussion. So we have done it here, in our lab environment. But if you prefer to actually download these, by all means, you can actually download these as and run them locally, right? So, but in the interest of class time and conserving class time, we actually run them here. Now, anything that we discuss, we are talking about it. We'll talk about, let's say this is a box plot, right? And well, this is a segmented box plot, and then from here we will use a segue into, well, how do you define segments, and then again talking about the behavioral segments and demographic segments, and how would you segment data behaviorally? What could be the behavioral segments if you're working for Amazon, if you're working for Netflix, if you're working for Google, if you're a search engine, you're an e-commerce company. And then coming up with this hypothetical examples, right? So let's say this was a segmented box plot. Now that we have understood box plots, but well, many people understand box plots, but how do you apply that in real life? I have this segmented box plot. How do I, let's say this is the revenue per user for my 3 different behavioral segments. What does it tell me about those segments? And now we talk about, they could be for an e-commerce company or for any business, it could be some demand side reasons and supply side reasons. So you can see that we are blending that discussion. It's not purely technical. It is not purely business. I mean, so in some cases, hey, I don't know how I got this, but I want to discuss the business implications. On the other hand, well, I just know how to create this. I don't know how to apply this. And then also that bridging the gap of communication. How do you discuss these? How do you hypothesize? What other kind of visualizations would you like to would you create or would you produce in order for you to answer more questions that happen or that emerge while you're analyzing this particular visualization? So it's almost, if you look at this, it's almost like a narrative, a story that we weave around this and this is what is going to happen in real life. Your ability to create plots, very helpful. Your ability to create visualizations, great. But your ability to impact or influence decision making or uh, change the business bottom line or increase customer satisfaction. Because at the end of the day, what we care about as a business is not you're not going to be hired to write code. You will be hired to have a business impact. So we talk about how can you be that data scientist who can have business impact as opposed to just any data scientist, I mean, who can write code. I can tell you from my experience, I have hired quite a lot of data scientists. I mean, maybe more than 100 data scientists that I have hired and in my career. And one thing that I have found out is that disconnect and the lack of understanding. Many data scientists, they think that it is only their technical skills that are going to matter. I've seen people failing because they rely overly on their technical skills. So we actually, through discussions, through anecdotes, through stories, through some exercises, we try to inculcate this idea that your job is to have an impact. Your job is to move some metrics, move the needle. Your job is not to write the code. Writing the code is means to an end. So we have that discussion on various angles. How do you explain this plot? How do you tell a story? How do you ask more questions? How do you answer those questions that you've asked, and so on? So we have this in-depth discussion on data and importance of data, and different anecdotes around metrics and KPIs and all of that around data. And we spent about good 4 to 5 hours on this topic, Then we move on to how do you collect data, and how do you structure a machine learning problem. When you're given a problem, when you're given a business problem, you're never going to be given a problem. Hey, here is a data set and go build this model. I mean, that's not how real world is going to be. You will have some abstract business pain point. You do not know whether you can apply clustering or regression or classification, or you won't need to build a recommender system on it. So we will actually inculcate that mindset using some exercises where we are going to actually show you how do you take a real world problem and translate that into a machine learning problem. So that's really what we do here. And once we have set these foundations, then we get started with different techniques. So we could start. We start with actually decision tree learning, and when we go to decision tree learning, then once again we will start with the discussion on how the discussion of supervised learning, what is classification, and what is regression, and all of that. And then how do you build a decision tree? And once again, the decision tree discussion is not going to be very superficial. We'll talk about all the issues in building decision trees, how many splits, how far you want to split, where do you stop, what is the splitting criteria, why would you use entropy, why would you use Gini value, and then once you have done it, we'll put all of that in action by looking at a lab. And if you look at this, we'll build a tree, and then now we'll come back and we'll look at it and try to understand, right? So why do I only have two? Why do I have only one split? Should I stop here, or should I continue splitting? Then I will modify something and then maybe add one more split. Okay, what does the tree look like? So develop that intuition and understanding of how to build a decision tree efficiently, and what are the limitations of an approach like this. Once we have done that, we are going to move on to evaluation of classification models. Why do we want to evaluate? Really, building a machine learning model is not very difficult. Anyone with some basic Python skills, I mean, they can build a machine learning model. Basic Python or R, MATLAB, any environment that you're using. But at the end of the day, the case that we make in this evaluation module is that building machine learning models, it is more of an economics problem. It is not really a technical problem fundamentally, because at the end of the day, maybe you don't need a machine learning model, and that's okay. So what we do here is we explain to you that you have to have some framework, some metrics to evaluate these machine learning models. How do you evaluate these machine learning models, or this classification model in this case? We have this discussion based on some scenarios, maybe fraud detection, customer churn prediction, maybe some kind of some high value fraud, some low value frauds. In what case you would consider recall and precision and F1 score and accuracy, and what are the relative trade-offs. And the takeaway is that you are not going to confine yourself to a specific textbook metric. You are going to actually look at the problem, and you're going to decide which problem to consider, or rather, which metric to consider for evaluation your machine learning model. And then once again, we will have the same thing every time when we finish a learning module. We are going to actually go ahead and discuss. There is going to be evaluation of that particular. If it is a classification model, we'll go through the evaluation of classification models. Go through this once again, discuss, and then connect the dots with the theory presentation that we made. Okay, I see that there are some comments. Let me read, and maybe there are questions, right? Okay, the last link that we shared did not work. Let me see. And my team is going to fix this link. Actually, it is, maybe you can try. But yeah, so yes, there's a question. Is this a recorded session? There's a question on Zoom. Yes, it is a recorded session. Then there is another question from LinkedIn. That as a high school student graduate can, yes, I mean, interesting. I'm glad you asked, right? So we have had, I mean, a few years ago we have had a high school graduate, and if you're decent, with a decent GPA, if you're a decent student, if you can code, like have basic coding proficiency, I mean, you can actually attend this boot camp. We have had actually high school students attend, and I know notably, I mean, one student who actually did this just before starting their college, and they ended up, getting internships during their college, a lot of internships and other, their other opportunities during their college, and then they went on, and now I think that student is that person is actually doing a startup of their own. So yes, I mean, if you're a good student, you should be able to actually go through the material with relative ease. But please talk to us. I mean, we would like to actually give you an assessment. I mean, just not assessment as in we are not going to give you a test, but we would like to talk and make sure that you get the most value out of it. We would like to understand what you're trying to get out of it. Okay, and okay, that sounds good. So the questions so far, I've answered those, and I will keep looking. Now, then we go on um, to the tuning aspect of it, right? So when you build models, once again, even if you know how to evaluate them, but what if the model looks good in only one instance, right? So we talk about the idea of the building a stable model, right? So no matter what random variation of data comes in, the model actually continues to perform. So we will extend, I mean, this discussion to how do you build a model that is reliable and it is going to keep performing in longer term. So we will talk about the ideas around bias and variance, bias variance trade-off. We'll talk about the ideas of overfitting and underfitting in a very, very detailed manner. It's not going to be some superficial overfitting, underfitting discussion. It's a very detailed discussion. I enjoy this session quite a bit because that actually it is not only in the context of machine learning and predictive modeling, it is in the context of any estimation problem. So we do that, and then we look at cross-validation, and then we actually fine-tune a model. Once we have gone through all of this, then we start making more progress. We start with more advanced or somewhat advanced techniques. We start with ensemble techniques, bagging, and random forest. And at this point, I would like to call out so that theory versus math versus practice balance. So a common question is, how much math do I need to know? All the math is going to be self-contained. So case in point, random forest. So if we are discussing random forest has this cannot be built without understanding of bagging. And bagging cannot be understood without understanding bootstrap sampling, which cannot be understood without understanding sampling with and without replacement. So we build that mathematical foundation to make sure that you understand why random forest works so well. Similarly, we will go ahead and build a random forest, apply a random forest model on a problem. Same hands-on lab, just like I've been showing you. Then we go to boosting. Again, boosting, we set the mathematical foundation. We talk about sampling distribution, and then how boosting actually alters the underlying distribution of data to come up with a better model, right? So, and then I'm throwing a lot of terms at you, but you would be surprised how approachable, how accessible these things are, as long as there is willingness to learn on, on the student side. We will also be getting into online experimentation and A/B testing. Think about this. Just like pharma companies, they do design of experiments for a drug. Similarly, large-scale online companies, they actually have this idea of running experiments on their users based on the color of the font, or maybe size of the font, maybe color of the button, maybe a different model. We talk about the fundamentals of those models, fundamentals of those experiments. How do you design an experiment in an online setting, and what are the pitfalls, and what kind of metrics, online metrics and offline metrics that we would use, and so on. So there's some detailed discussion that is going to be there. Then we also get into the fundamentals of text analytics, and we recently actually introduced a module in Data Science Bootcamp that we did not traditionally teach, is Introduction to Large Language Models. So we have a full a bootcamp on large language models, but this is enough of an introduction where we actually tell you, what is all of this buzz about, what is RAG and what is fine tuning and all of that, but a very high level introduction, nothing very detailed, 2 to 3 hours to give you an idea of how do you handle text and how do you, use these large language models. Then we go on and talk about unsupervised learning and k-means clustering. When you don't have labeled data, what do you do? How do you cluster your data? How do you do unsupervised learning? And once again, hands-on exercise. How do you find that your model is good enough? Where do you stop? Do you want 3 clusters or 4 clusters or 10 clusters? We talk about all of that. Then we move on to regression. Regression is an intense module. We get into the business of, we explain regression starting from an equation of a line, give that into an intuitive explanation of what are the parameters or coefficients of regression, explain, that essentially there are slopes in that equation. Then we go on, explain the idea of derivatives and gradients and gradient descent, and how do you come up with an optimization criteria, understand all the regularization business. How do you regularize a model? How do you control overfitting in a linear regression model? And then really go ahead and do a hands-on exercise where we actually tweak the penalty parameter and then see that the model is working better when we are adjusting the penalty, right? And so then we also get into ranking and recommendation systems. It is another category of problems. If you look at this, we start with visualization, just ad hoc understanding, visualization, and hypothesizing of data. But when you're formalizing building a machine learning model, you can be doing classification, you can be doing regression, you can be doing clustering, or you could also be doing some kind of ranking problem. And we understand what ranking entails, and we are going to actually also emphasize how to evaluate a ranking and recommendation engine. I should have mentioned that we will also be doing this evaluation for regression models. So anytime we learn to build something, we are going to make sure that we understand how to evaluate it. So in this case, we'll start with, in recommendation system, mean absolute error, RMSE type metrics, but then we'll shift our focus towards more ranking oriented metrics like NDCG and all of that. And those of you who are familiar familiar with some ranking problems, right? So basically, once again, it is a curriculum designed by practitioners for practitioners. So anyone who wants to be a practitioner, you will you will actually have people who have actually built these systems and actually done these things. It is not just some textbook knowledge that they are just presenting using some slide deck. So everyone has, that's this background in whatever they're teaching. And then in the last two sessions, we are going to actually give you some background in big data, data engineering. We'll actually discuss, the why do you need this distributed compute? Why do you need this distributed file system? How are they different? Then how are the apps different? What is a bare metal deployment? What is an on-prem deployment versus what is a VM, and how do VMs look like? And from VM to containers, and containers to more function-based deployments. Why are we doing this? Because as a data scientist, you must be able to you must have some working knowledge of data engineering and deployment of apps and general cloud computing. If you do not have this understanding, it is very unlikely that you will be able to move at a fast pace. It is almost like you are that master chef who's dependent upon you can make a great dish when if all the ingredients are available. But the problem is you're dependent on someone else to get those ingredients. Well, how do you get those ingredients? Someone else will give them to you, and if they use a wrong filter, if they run the wrong query, if the data quality has issues, then you are completely dependent on them. So you must know a bit of that data engineering in order for you to be able to do data science effectively. So we will give you access to a data warehouse. You will run your queries, and those queries will actually show you how to build a random forest model, how to build a random forest model on a million rows of data. And then basically, that's the idea. So we'll give you a little bit of background in big data engineering. How do you build models? How do you process data when the data sets are huge? And in the last module, we actually do real-time analytics. You're going to build an end-to-end real-time analytics solution where we'll give you a data source, and we'll give you instructions. I mean, we'll have them some source of synthetic data. That data is going to just flow through this pipeline at various stages. You will set up a message queue, and then that message queue is going to basically it's going to pass it to a real-time stream processing engine, and then you will build a dashboard of data. You push data from here, and you have a real-time analytics dashboard. We have a predictive modeling competition in class as well, and then we basically have this spirit of the competition that within the class everyone's competing, and then every day they learn something new, and then they are improving their model, and then we have this in-class data science competition, and we announce winners on the last day of the boot camp. So we have a lot more material than what you see here in this module. We can only teach so much in 40 hours. I mean, how much can we teach in 40 hours? Maybe there's another 40 hours that I would like to teach, but of course, we cannot spend that much time in training. To that end, you have a lot more material that is available at your disposal. For instance, if I click here, this is our machine learning sandbox. So if I go and click on, say, random forest, right? So if I went ahead and now if I search, so and now you have more exercises. You know these things in theory. You're aware of these things in theory, and now you can actually go and run these code samples, and then just run it and find out what all of this is about, right? So basically, it's think of this as not just a course. You will have access to the learning resources even after you go back. I think this will take a while to complete. I will just leave it there. And we have, you can see that you already know what out of bag errors are based on the discussion that we did in class, and now you can go and do this on your own. Now, we are probably one of the most well-known companies out there in terms of, I mean, these are all the companies. I mean, if you look at this, more than 3,000 companies have attended our training. If you look at this, there is hundreds of people on video. I don't think any other data science training company has that many people in video from all over the world, from any company that you can imagine, right? So these are real people. You can reach out to them. They are working for big major companies, and these are alumni companies, and these are the alumni. You can search. I don't know, maybe Microsoft. Let me search. I will search here, Microsoft. You can see that there is a bunch of people from Microsoft. I don't know what other companies. Bank. I don't know which bank, but you can see which bank. So you can see that there are people who have attended our trainings from different banks. And these are real people. You can reach out to them, talk to them, and find out from all over the world. So we are, as I said, I mean, in terms of credibility, these are all the real people who have actually attended. We are not actually reviewed by John Doe and Jane Doe. These are actual people who have attended, and these are all the people that I showed you from different banks who have attended our trainings. And let me go back to questions. Okay, I will. I have been working in the insurance industry for past 15 years, and I'm looking to transition into data science. During my undergraduate studies, I'd studied math and statistics. What advice would you give to someone with my background who's considering this shift, and what will be the career path? Nitesh, this is a very, very detailed question. I do not know. I don't know if I can answer it. Let me just set a 1 minute or under 1 minute um, limit on my response. So data science is about doing and actually implementing things. Data science is not about training courses. Data science is not about attending as many courses as you can. It is about learning something and doing it, and then again learning something and doing it, right? So work on real world projects, work on real problems, and then that would be my recommendation. If you already have a background in math and stats, you have the right foundation already. But the programming aspect is very important. As a matter of fact, I consider programming to be a little more important than the math and stats component, right? And this is based on my understanding, because sometimes, based on my understanding, actually managing a lot of younger data scientists. Because one thing is, sometimes people think that, hey, since I don't like coding and I don't want to write code, let me just go and become a data scientist. And guess what? You have to write a lot of code. Of course, you don't. In many cases, you don't write code that is customer facing. But still, for that rapid prototyping, that analysis, and internal customers, you have to write code, and you should have a very strong ability, and you should be competent enough to clone any Git repository, to be able to call any API and go and get any API key from any service and be able to actually manipulate. So in many cases, the machine learning and the AI components, they are actually abstracted. They are available as a black box. But the plumbing that you do, it requires your coding skills. So Nitesh, with your background, I would say that if you spend time on the coding angle, spend a lot of time on practicing, see how things are done. And that's what we try to do, actually expose you to the entire ecosystem. What we try to do is not teach you everything. No one can, right? So anyone who claims that they can turn you into a data scientist, they are either they don't know what they're doing or they're lying. We will never tell you that you will. I mean, we have been in business probably for the longest time. Not even once we have mentioned to anyone that you will become a data scientist after the boot camp, because simply a 40-hour training is not enough. But we will enable you so you become a data scientist. And whether you become a data scientist or not, that's your own undertaking. You are going to spend the time, the due time, you will spend the due effort. And then if you leverage all the resources that we have, you understand the material. Yes, I mean, a lot of people go and check out our website. People have gone to very high positions, right? So, and leading data science organizations. But I mean, it was their own effort. Yes, we enabled them, but at the end of the day, it is them who decided how successful they are. Can I get the PDF? If you fill out one of the forms, yes, we can send you the curriculum PDF. I'm assuming that is the case. What is the fee? If you can, I'm not sure because the discounts keep changing based on the demand that we have. So if you can check out our website, and we can, I think someone from my team, they are going to post the link to if you go under bootcamps and click on Data Science Bootcamp, not the large language model bootcamp, but the Data Science Bootcamp, check it out, whatever the discounts are. And then if you're a student, if you are, if you have any reason for anything, I mean, we definitely would love to help, but, just let us know, what we can do. How long will you have access to the learning sandboxes? Legally, I'm required to tell you, maximum is 1 year, but we have never cut anyone off, right? But it is going to be at least 1 year. Let me put it this way: legally, I'm required to tell you, right, sometime give you some time frame, but otherwise, I mean, we are cool with it. I mean, the infrastructure is there, so why not? I mean, just come and use it anytime. Okay, how much is this course for? I think once again, please take a look at this, under here, go to the website and under Data Science Bootcamp course, check it out. I am an AI student, so currently serving my skills in AI, but also want to be a data scientist. So can I relate my... Hmm. So let me read that question out so others can also understand. I'm an AI student currently learning AI, but also want to be a data scientist. So how can I relate my learned skills of AI and data science? Will my skills help me out in data science path? Really, I don't like looking at things in terms of titles. Develop the skills and start solving problems. I mean, let me phrase it a bit differently. Don't worry about titles, right? So, just learn something and have a business impact, because you would be surprised in some cases, someone with a developer role might be doing a very deep data science and machine learning work, and someone with a data scientist role might be just writing simple SQL queries or not doing anything. So I do not know how to answer this question, right? In general, will AI skills help you in data science and the other way around? Of course, they will help each other, but it really depends upon really what you're looking for. It's really, I mean, I don't have enough context to actually answer this question. So, but happy to, if you set up a call, happy to, help you out in that. Okay. Let's see. Are there any other questions that may be there? I'm happy to take any more questions in case, but otherwise, if there are no other questions, please set up a time with us. If you need to learn, and one of us can answer these questions in a more in a Zoom call or in a meeting. Happy to answer any questions. How we can help you. How the boot camp can help you achieve your goals. But we have to know your goals, what you're trying to do in order for us to be able to guide you. Okay, since there are no more questions, I am going to, maybe I will give you everyone a few more seconds. In that case, thank you, everyone. I hope to see some of you at the bootcamp, the next bootcamp in Seattle. Thank you.